In this video, I'm planning to explain divisibility rules again, and we learned divisibility by 2, 3, and 4. Now we are going to continue with 5, and here this is the one of the easiest one because it's related with the ending number. If the number if the number ends with 0 or 5, then it is divisible by 5. So for us, the most important digits are the last digit. And here, if I give some simple examples, let's say 103 is not divisible by 5 because it's not ending by 5. Or 120 is divisible by 5 because it ends with 0. Or 725 is divisible by 5 because number ends with 5. Here there is another example, and it says that M235M is a 5-digit number, so these are representing digits, and it is divisible by 5. If it is divisible by 5, there are two possible cases. One of them is 5, the other one is 0. And here 5, 2, 3, 5, and 5 it can be, or 0, 2, 3, 5, and 0 it can be. M is equal to 5 or M is equal to 0, but M is equal to 0 is not possible because numbers cannot start with 0. That's why this is 4-digit number. This is 4-digit number, and it says in the question it is 5-digit number. Only the solution is 5 going to be. Okay, now we are going to continue divisibility by 6. Natural number is divisible by 6 if it is divisible by 2 and 3. Or they are using also this definition. Divisible by 2 means even number. So if even number divisible by 3, it's divisible by 6. Here we have example 235MN is 5-digit number. M and N are digits. So if it is divisible by 5 and 6, it means that it is divisible by 2, 3, and 5. That's why it's easy for us to find the last digit, because divisibility by 5 is related with the last digit. So N can be equal to 5 or N can be equal to 0. But if N is equal to 5, the number cannot be divisible by 2, so N cannot be equal to 5. That's why N must be equal to 0. So the number is 2, 3, 5, M, and 0 it's going to be. Then second part it's coming. At the second part, number is divisible by 3 if the sum of its digits is divisible by 3. So we should check 2 plus 3 plus 5 plus M plus 0, is it divisible by 3 or not? Here 2 plus 3 is equal to 5, and plus 5 is equal to 10. It's going to be 10 plus M is equal to what? This is our main aim. Now, in the previous questions, when it is divisible by 3, if you remember, we were trying the numbers, and possible M values are, M can be element of 0, 1, 2, till, if you remember, 9. So we should try the numbers. And as I see, the sum is 10 plus M. That's why if M is equal to 0, the number 2 plus 3 plus 5 plus M, not plus M, 5, 0 and 0 it's going to be. This implies that M, again I made a mistake, sorry. 2 plus 3 plus 5 plus 0 plus 0 is going to be equal to 10. And 10 is not divisible by 3, so 6. Okay, if m is equal to 1, 2, 3, 5, 1 and 0, this implies that it's going to be 2 plus 3 plus 5 plus 1 plus 0, which is equal to 11, and it is not divisible by 3, so it's not divisible by 6. Here the last one that I am going to try, because with respect to this one we are going to decide for the others. M is equal to, if m is equal to 2, 2 plus the number it's going to be equal to, it's going to be 23,520, and the sum it's going to be equal to 10 plus m, which is equal to 10 plus 2, which is equal to 12. So it's divisible by 3, so 6, and it's divisible by 5 because it ends with 0. So m can be equal to 2, n is equal to 0. M is equal to 2, n is equal to 0. It can be, but there are more numbers. If you remember, we will try 2, 3, 4, 5, 6. We should try all these numbers here. But when I see 2, and if it is divisible by 12, it means that the order also, the sum of the digits are, if you follow this part, 10, 11, and 12, it's going to be the next one. If m is equal to 3, the sum is going to be equal to 10 plus 3, which is equal to 13. So the order also increasing one by one. 13 is not divisible. The next number that is divisible is 15. If m is equal to here 5, and if m is equal to 5, if m is equal to the next number, if m is equal to 8, it's going to be 2, 5, and 8. The difference between them also it's equal to 3. So if m is equal to 8, then the sum is going to be equal to 10 plus 8, which is equal to 18, and 18 is divisible by 3, and so 6 and 5. Yes, the numbers n is equal to 0 and n is equal to 2, and the solution set for this one, because it's written all possible values, m can be equal to 2 and n is equal to 0, m can be equal to 5, n is equal to 0, or m can be equal to 8 and n is equal to 0 going to be. And divisibility by 9, it's similar to divisibility by 3, that's why it's easier a bit. The natural number, the sum of the digits are divisible by 9, then it's divisible by 9. It's like 3, if the sum of digits is divisible by 3, it's divisible by 3. We are going to accept like that, and with respect to that one, understanding the divisibility by 9 easier. Okay, 3, 6, 5, m, and 7, 2 is 6-digit number, and which divisible by 9. Find the value of m. Here again we are going to add the digits. 3 plus 6 plus 5 plus m plus 7 plus 2 is going to be equal to 3 plus 6, 9 plus 5 is equal to 14 plus 9 is equal to 7 plus 2, 9. 14 plus 9 is going to be equal to 23. So the sum is equal to 23 plus m. And the closest number that's divisible by 9 is 27. So which number that makes 27 for the m here m can be equal to 4. The next number, 23 plus m is equal to 27, so m is equal to 4. It is going to be m, can it be greater than 4, like 6, 7, 8? No, it is not possible, because 25, if m is equal to 5, it's going to be equal to 28, and 28 we know it's not divisible by 9. The next number that's divisible by 9 is 36, and for the 36 is 23 plus m, and m is going to be equal to 13. It's going to be, but this is not possible because m is digit. So if it is digit, it must be the element of must be the element of 0, 1 till 9. The maximum number is 9. That's why m cannot be equal to 13 here. The next question is going to be classwork for us. In the class, we are going to try to solve this question. Numbers are divisible by 10 if they end with 0. So the last digit is important for us. If the last digit is 0, then it's divisible by 10. Here 270 I can give as an example. 270 is divisible by 10, but 822 is not divisible by 10 because it's not ending by 0. Here the 11 is a bit different. We should count the digits. Here the count the digits, we should find the sum of digits, even digits and odd digits, and the difference between sum of the odd digits and sum of the even digits must be 11 or 0, multiple of 11 it says, and we are accepting that the 0 is one of the multiple of 11 also. So here if I number the digits 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, here the number of digits, these are the place of, this is even, this is odd, the one is odd, 2 is even, 3 is odd, 4 is even, odd, even, odd, even, odd, even, it's going to be. And we are going to compare like this. If the difference between even digits, 5 plus 6 plus evens, even, 5 plus 6 plus 3 plus 9 plus 0, that makes 23. That makes 23. And odd number digits are odd numbers 6, 1 or 7, 4, 5, 1 and 6 again. Here also that makes this makes also 23, and even minus odd, if it is equal to 0, then number is divisible by 11 is going to be. And again I'm repeating, a natural number divisible by 11, the sum of its digits or odd numbered digits and the sum of even numbered digits difference is multiple of 11, or I need to write here 0 not to confuse that one.